Okay, guys, thank you very much. My name is Joe O'Halloran, and networking editor of Computer Weekly. I'm delighted to be at this panel of AI infrastructures, what's coming and what it means for the ecosystem. Now, these days, there are very few certainties in life. But what you could say, in addition to death and taxes, I think there's been massively increased workloads on infrastructure through AI. And as IOWN celebrates its 5th birthday, I think it's tempting to look back over those 5 years and just think of what we all thought AI would do in 2025. And as Gregory very eloquently said just now, AI is certainly nothing new. But it's safe to say that hardly any of us knew just how much AI would grow so strongly, by how much, the types of AI we'd be using, and where it's deployed. And I've got to say, Gregory really frightened me by saying AI is being used as a lawyer or a therapist. I think I'm a bit too old for that one. But we have to deal with the world we live in. And what is this world? I get every day messages from the technology industry and the ecosystem about what AI will do. I'm just going to call out a few things that really struck with me, because I think they encapsulate what is going on. Kai Prigg, the Executive Vice President, Enterprise Operations at Lumen Technologies, said this very bluntly. AI is fueling a surge in network demand like never seen before. And I don't think many people would argue with this. Steve Smith, the CEO of comms infrastructure firm Zayo, keeping pace with the next wave of AI growth will require new long-haul networks to enable the rapid scaling of capacity needs. And that's in both existing and emerging AI data center net markets. Now, Zayo did some predictions. They reckon over the next 5 years, data center capacity is going to grow 2 to 6 times. That could be very conservative, the way things are going. And I'd always like to check out the company Ciena, proud IOWN member. AI capacity doubling every 6 months, with the net result of hundreds, if not thousands, of fibers connected to data centers being lit up, and then some. As you can hear, I'm from the UK, and closer to home, our leading comms provider, BT, released some very interesting information earlier this year about its key network challenges and requirements for its business network operations. Key thing, a huge impact on its network through AI training models. What it predicted was the movement of massive data sets. In fact, it described them as elephant flows, continuous transmission over extended time of massive amounts of information. And what issues did this bring? Well, they were looking at tail latency, job completion, network inconsistencies, accuracy, congestion management, scalability. Coming into IOWN, I hope some of you here were in Stockholm in April, a very, very interesting meeting of the European branch. And analyst Omdia, who are now a stablemate of Computer Weekly and the Informer Group, they published a very interesting white paper, which I would really recommend anyone seek out and read. And I'll just quote you what the top line was. To drive the continued growth of the global AI economy, optical networks will need to evolve significantly to deliver the enhanced capabilities needed. Not just deploy optical networks, significant evolution. Omdia calculated that data center capacity would grow 57% in the period 2024 to 27. Lower latency would be required to meet advanced application and service requirements. The cloud-like agility to match bandwidth for supply would be the basis of service utilization. Yet in addressing the surging capacity, Omdia was very, very keen to emphasize this all had to be done within very tight CapEx targets. But I don't think there's a company out here who's getting more money from their budgets for CapEx. The other key thing, and again it's been mentioned all week, about power consumption. These optical networks that are there would see reduced power consumption a bit to meet sustainability goals and reduce energy costs. Think of this now from just the business benefits of this. They also predicted greater network robustness and security was required. Well, that's kind of table stakes. The good news, in conclusion, from Omdia, that it and everybody else in this room can see IOWN and the Photonic network as a solution to this. And that's what we're going to concentrate on today, looking at the three basic pillars: capacity, latency, energy efficiency. And if we see what IOWN and APNs deliver, these optical technologies that can make those reduced energy consumption costs and do it significantly as required. Key to this, deterministic quality of service, latency bound to a specific value. Think of institutions like finance houses. That is so important. There'll also be support for new data transfer protocols, but there'll also be much more, and we're now about to hear. And what we, and by we I mean these guys, we're going to discuss these issues and offer real solutions about what's coming for infrastructures and how the ecosystems are going to evolve. I've got three brilliant domain experts here who can put into context what's coming next and what it means precisely. First of all, we have Stephen Lim, the Senior Vice President of Marketing at NTT Global Data Centers. Rick Lievano, CTO Telecom, Microsoft. And Geng, Chief Technologist for Wireless Standards in the Platform Engineering Department of Intel. What we're going to do is keep this conversational. Rick, Stephen, and Geng will deliver insights from their own domains, taking about 10 minutes each. We're going to focus on solutions and outcomes. And then in the time that we've got left, we'll probably got here till about, say, 3:30, I'm going to ask them questions to drill a bit deeper. But most importantly, and I can't stress this enough, what we're going to do is talk about what can be addressed and achieved under the auspices of IOWN. So please do enjoy what we've got for you in the next 40 minutes or so. And I think that's enough of me. Without further ado, it's over to you, Stephen.
Yeah, thank you. Really excited to be here. I think it's interesting. We've heard a lot, and I agree, Gregory really categorized it well, what's happening. I'm part of our Global Data Centers organization. We build and run data centers around the world. We're kind of the foundational piece of a lot of what everyone's talking about with AI, with infrastructure in general. When we have these conversations, Vito and I were chatting about this yesterday, really, what does IOWN mean and where are we at within the data centers piece specifically? And so if we look at what's happening in the data center industry, the demand continues to grow exponentially. We can't keep up as an industry with what's happening in demand. And if you think about the history of that, you go back the last 5 to 10 years, driven primarily by the hyperscalers, the large cloud providers, who were both building data centers and leasing data centers around the world. And that's been growing at in excess of 20% year over year for many, many years. In the last 2 years, on top of that, we've now seen this push for AI, which is adding, by some estimates, an additional 20% year over year growth. That is a dramatic demand curve that the industry is struggling to figure out how do we deal with. What does that do in terms of where the constraints are? The two primary constraints that's driving, one is, as Gregory talked about, power and availability. It's a fascinating statistic that there hasn't been new power generation in the US. I'm not surprised, but I wasn't aware of that definitively. The fact that we're not increasing our power output to account for this increasing demand. We're seeing that in everything we do. Part of what we do when we look at development is starting with power. I can tell you if we go back 10 years ago, we never looked at power. We assumed wherever we were going to build, we had power and we could get it. We can no longer do that. So we're talking about power as that starting point. What goes hand in hand with that is where is the location? And the traditional data center model, the traditional networking model, is a concentration in a few small areas to manage latency. The availability zones that Microsoft talks about and deals with is really set that standard where you have to be in a very specific geographic area. And so that makes it very challenging when you get into urban centers, particularly in places like Japan, where you're trying to build in Tokyo. There's not a lot of extra land to build large-scale data centers. And the data centers are getting bigger and bigger and bigger, as I think everyone in this room knows. And so one of the things that we're most excited about it with IOWN and the APN networks is how do we solve two of those major constraints? Well, the first is the fact that we can now start to distribute data centers in different locations. We don't have to be as concentrated. We're not losing that latency and we're not losing that bandwidth. And so as we look at that, and we've done a couple of tests in Virginia and in London and in India as well, and we're seeing that we can now look at places that maybe are farther outside those traditional AZs. And so that's exciting when you think about that. We can now look at where we want to be and find lower cost areas or places that may have power availability. The second that is really kind of more future focused is the fact that if we can lower the power usage, we can then extend what we can do within a given footprint of a data center. One of the big challenges with AI in particular and the GPUs with NVIDIA, high power consumption means high heat creation. A very obvious statement, but how you deal with that heat is difficult. Traditional data centers all use air-cooled. As an industry, we've mastered that. We do that really, really well. That doesn't work for high-density deployment environments. The joke I always say is it works, but your wind speed would have to be in excess of 100 miles an hour. And so try working in a data center with 100-mile-an-hour winds blowing constantly. It's just not going to work. And so everything is moved to liquid cooling. And so you have to have a different design. That cost of that build is significantly higher. If you think about the net effect of what's happening in IOWN and APN and where it's going, if it lowers that heat output, maybe we don't have to put in such robust infrastructure, liquid cooling and heat exchangers, and maybe we can extend air-cooled and other solutions. I was talking to someone earlier today about that, and what I get excited about on that one is we also have aging assets that are leveraging older technologies, air-cooled, things that will not work for today's AI deployments. If we're able to deploy, solutions that use much less power, maybe we can extend the life of those. It's a very different sustainability story, but one that we really like because the alternative is either rework or tear down and rebuild the building, which is obviously not a cost model that we want to get into. And so those factors for us are super, super exciting, and we're, one of the reasons when Vito called, I was jumping to come and be able to talk to everyone here, to be able to hear more about where it's going, but helps us think about how we can solve some of those things in the future.
Thank you, Stephen. Now, again, when we do in the background, Rick and I were talking, and I think everyone knows about Microsoft's key role in AI, and infrastructure is absolutely expansive. But there was a phrase we used before about avoid creating a storm of noise that ultimately you take one step forward and two steps back. Mm-hmm. And that's what I'd like to draw out from you, Rick. The experience of Microsoft, what needs to happen going forward.
Yeah, thanks Joe. Pleasure to be here. So I'm Rick Lievano. I'm the CTO for the telco industry at Microsoft, and I'm responsible for Microsoft's technology strategy as to how we address the needs of operator partners. Yes, we know a thing or two about AI at Microsoft. So our last fiscal year, we spent upwards of $80 billion. So Greg, we're on target to hit that 350, or at least be part of that 350 billion. For this fiscal year, we're on track to actually exceed that by a significant number, right? So as you can tell, we're spending a lot on AI, on data center infrastructure, and of course, on the network that connects everything, right? That's the critical piece. We got to light up those data centers with the networks from our own network that we built, as well as those of our partners, many of you who are here today. We're building this capability, this AI foundational capability and capacity, not for ourselves necessarily, but for our enterprise customers, right? So that's really the primary need. Yes, of course, we also eat our own dog food, as they say, and you referred to one of those challenges, which I'll speak about in a second. But the reality is that it's really a network built for enterprise customers. We like to say that we are now in the process, or we built the network for AI to deal with a lot of these challenges that Greg spoke about. And we built the network for AI by infusing AI in the network. And so that's absolutely key. We would not be able to scale our network using traditional means and essentially hiring more headcount each time that we grew our network to try to keep up with the growth of AI. And so AI, of course, becomes an intrinsic and critical part of our investment. Now, interestingly enough, you mentioned what are we doing in the network? Well, AI is not just on the network, of course. It's across the business. We work with our telco partners on a daily basis. Of course, I have great conversations. And we feel that telcos are really investing in AI across their entire business. It could be around elevating customer experiences. Of course, that's where AI exploration begun in most of the telcos, right? Let's go into the contact center and try to create better experiences, improve NPS scores and such. And from there, it's ballooned across the entire company. So we see AI transforming business operations. All those legacy OSS and BSS systems are now being fronted by AI agents that can really automate and streamline a lot of those processes. We see it around modernizing the network, and I'll spend a minute or so on that. And lastly, we see AI now as a way to reinvent the products and services telcos have had for generations, right? So think of AI infused in the carrier voice network and the types of services that you can deliver. AT&T just announced last week a personal AI assistant that's actually bound to the mobile voice network. And so that's a pretty exciting new potential revenue opportunity. With our partner NTT, they've developed Susumi, which is a Japanese language model, which they now monetize and create new revenues by publishing it to the Azure Marketplace in the Azure model catalog, enabling our shared enterprise customers to use this really great Japanese first-party model. Now, around the network, we've built an absolutely gigantic network, 500,000 kilometers of fiber, first-party fiber across the world, and of course partnerships with telcos across every single country where we operate. And to run such a network, it would not be possible without the use of AI. And so we've invested in AI. We've been investing in AI for years. Certainly, it was really interesting to hear the various different generations. I can tell you that we've done it all over time. We've been in the trenches. We have our best practices, and we've taken a beating. We know what works and what doesn't. And so one of the issues that Joe mentioned, for example, and one of our lessons learned is, yes, in that second generation of AI, we invested dramatically building complex machine learning models to ingest more and more and more data to be able to examine anomalies real time and be able to predict potential failures. And that worked well for a while. But as the life cycle of these machine learning models got more complex, as the models got bigger, the ROI just didn't keep up. The models generated more noise and more false positives and created more work than the problems they were solving, right? So we have to take a look at some of our current practices and determine, are they still viable in this third generation of AI with generative AI and AI agents, and can we do things better? And so, we've reverted to using tried and true statistical methods for anomaly detection, for example, which simply worked well enough, and we can now move on to other areas where AI provided a better ROI. So, for example, quickly redirecting traffic to avoid any kind of disruption. Now, the way that we've also moved this as part of the Azure networking team, who's responsible for running our fiber network, is by really creating a multi-agentic AI framework, which we, for internal use, which we call NetAI. NetAI is rather novel in that it basically creates I would like to say an army of agents, but marketing told me to stop using the term. So let's just say a constellation of agents that are subject matter experts across your network. And so they really understand your troubleshooting guys, your MOPS and your SOPs. They understand what equipment you have there, your network inventory, your trouble tickets. And then based on the subject matter expertise of the agent, they're able to assist either a human operations or admin interactively, or they can be fully autonomous and in fact resolve an issue completely on their own. And so that's that's kind of the realm of where we are. I'll speak just briefly on one of those agents whose name is Miles. Yes, these agents have names. They interact with humans. Many of them are indistinguishable to humans, which kind of break one of my responsible AI tenets, which is, AI should always identify itself as being AI. Now, Miles, of course, does do that, but Miles behaves so naturally that sometimes it's difficult to tell that it's an AI and it's not actually a human. Now, one of the things that makes Miles quite successful, Miles is essentially our troubleshooting agent for fixing fiber outages, right, and working through those workflows. Completely autonomously, right? So it can actually respond to an anomaly, respond to an email message with an error or Teams, and then from there, kick off, create the ticket, work through the ticket. More importantly, work with our external partners, because again, we have partners in 100 countries across the world, where of course we don't always have first-party resources. These partners are from third parties. They may have their own methods, procedures, languages. Miles needs to understand all of that, and it can do so very well. And interestingly enough, after say all of the life cycle of the ticket completes, Miles is able to now do a quality check on the fiber repair and ultimately close the ticket, all fully autonomously. And so that's a really great success story we've had with that one.
Thank you, Rick. Now, Geng, just compliments with these two guys have just said. Intel needs no introduction, but perhaps what does need an introduction is the work Intel is doing within IOWN and the types of solutions, what you're working on with regards to AI, machine learning, language models, and the whole transport issue. Please.
Yeah, thank you, Joe, and thank you for inviting me to the panel. So I'm Geng Wu. I'm the head of next generation and standards part of Intel's the edge network edge group with a special focus on 5G and now 6G technology and infrastructure development. So as Joe mentioned, so I will focus primarily on how we actually build the AI infrastructure, what are the challenges, what we are learning, and most importantly, how we see the future directions and the AI technology and our platform capabilities, how we evolve that. So from a semiconductor components and platform AI infrastructure, the platform provider perspective, we basically see three fundamental capabilities that we need to provide to the market. The traditional networking capability, then the data management capability for AI and user application processing, and also the computing capability, obviously, for the inference and machine learning purposes. So if you look at the history of every generation of wireless system we developed, so we are basically in 6G in particular, which is AI-centric generation that to be targeting for the deployment of in around 2030. So we are basically evolving from a one-dimension engineering challenge, which is networking, to actually three-dimension challenge, system design challenges that involves the networking, computing, and data management. So fortunately, we're not actually from scratch, developing everything from scratch. If we look at the 5G, 5G actually laid down some the groundwork, on edge computing, and also in the core network we have the service-based architecture, which actually further enable us to go cloud native and AI native in the next generation. Having said so, the challenge in 6G is still unprecedented. As I already mentioned, we're going from a 1 dimension to 3 dimension with exploding complexity, and for internal, the system internally is becoming more complex, and network automation is becoming essential, and the services capability we offer, for example, AI-enabled interface, is actually certainly becoming a design challenge. The system also is instead of just moving, instead of just the moving data around for customer payload, now we're actually doing the processing data, generating data, and support the internal consumption and also the user consumptions. So this means that the system, if you look at what we are going to have in the next generation, starting from 2030, is that you will see the system evolving from the wide area network, which we actually are familiar with, to the wide area cloud, distributed cloud. So, and now, as an engineer, when we actually design a next generation platform, we certainly, the ideal situation is that we have a very concrete and fixed design requirement and objectives. However, that's not the case here. It's certainly challenging, but also is the fun part. If we look at AI, it's rapidly evolving. It's actually at a much faster pace than people actually comprehend. For example, Intel is basically envisioning the AI evolving from hyperscaler data center AI to Gen AI slash the agentic AI today, and to actually ultimately the physical AI, and everything powered by the artificial intelligence. So, so this means that from the workload and the point of view, we're basically seeing from the demand evolving from homogeneous, centralized client-server type of applications to more heterogeneous, distributed, and device network collaborating computing. And also, there's a rapid development in using pre-trained model to actually adaptive model in real time. And so all those basically require the transport network that actually enable and support such a system to be really order of magnitude more performing, and in terms of capability, in terms of configurability, and also latency. So there are several important things everyone talk about. For example, we need cost efficiency. And as many speakers already mentioned, AI obviously is not cheap. And if we really want to further grow the market and apply the technology to benefit everyone, being efficient in development, deployment, operation, and evolution, reconfigurability is actually essential. And this is a part of the technology that IOWN Global Forum is focusing on, and we are very excited about. And it also need to be energy efficient. Historically, energy efficiency is mostly about the cost, the utility bill. However, nowadays, as many speakers and Gregory in particular mentioned, that really is actually becoming a factor of feasibility, and we have to conserve power to be sustainable. And one particular thing, actually, in particular for 6G, I would like to highlight here is that how can we efficiently support the fallback capability in our platform. What fallback means is this. What we are doing today in the 5G Advanced and the 6G is that we are starting to look at different interface processing blocks, replacing them with AI-enabled function block. However, in the foreseeable future, we do anticipate the need to support fallback as an essential function, and for many, many different reasons. We're operating in very diverse environment, a very challenging environment, and there's a maturity of the algorithm, AI capability, et cetera, so we need to fall back. However, this actually put a unique challenge to the platform providers, which is ultimately at any moment, you are going to actually use either the AI-enabled function or either the traditional implementation. What you do not want to happen is you actually implement both and then use half. And another important thing we're actually getting from operator community is that everyone needs the system to be far more cost efficient. So therefore, really, how to try to support the fallback capability without throwing out almost half of the cost, hardware and software. That's actually a unique capability. Now, back to IOWN Global from Technologist. So as everyone very familiar with, there's an APN, all photonic network. There's also a DCI, data-centric infrastructure. So that principle, actually DCI principle, has been pretty much used in our platform design principle. And so in conjunction with the APN technology, basically we achieved the full programmability across every layer, from the service layer to the capability layer, platform capability layer, to the transport layer. We are able to actually achieve full programmability, configurability across layers. And the search actually design is in fact essential to adapt to the rapidly evolving system requirements, as we basically learning from real life that agentic AI actually there's so many type of agent, and the workload really is dramatically different. The signal processing, the data, amount of data, where the model reside. So they are actually, we do need this capability to actually manage this practically in almost real time to keep the system running and efficient. And then high performance transport is essential. And we need data rate, we need tremendous bandwidth, we need ultra low latency, which is the forum here is focusing on. So to summarize, from Intel, what we are doing really is that we envision the future AI infrastructure really need to be open, disaggregated computing and data management infrastructure powered by modern transport technologies developed by, including APN. It needs to be software configurable, scalable, expandable, and it need to be fully interoperable and at a global scale. So therefore, standardization and open implementation is critical, and it need to be efficient. And so one particular thing we did was that with our Geng processor, with the purpose-built accelerator, we're basically able to support efficiently the 6G interface workload without throwing away anything. And so the focus really is energy efficiency, cost efficiency. We need to minimize the complexity, because you go from 1 dimension to 3 dimensions, this is going to be, if you are not careful, this is going to be easily out of, the exploding into a disaster. So we also want to support interoperability at a global scale. Thank you.
Thank you, Geng. And I think that word interoperability has been used a lot this week. It's been a very interesting presentation yesterday from AT&T, which I found particularly interesting. But this whole wrapping this in IOWN and how the project's evolved, I'm getting a sense now we're at a tipping point in so much as the technology you guys can bring to the party is unquestioned. Are you now having to have different meetings with different people to say, here's what we can do, here's the business benefit, this photonics network, its capability is unquestioned. Get different people in the room. Just start with you, Rick.
So, yeah, I mean, I would say for the most part, and I'm more focused on the AI side of the equation, right, as to how you can ultimately use AI to drive operational efficiencies, in addition to any additional network investments you do on photonics or anything else. The era of POCs and pilots for AI is over, right? And so if you're still investing in trialing or determining whether the capability or the ROI is there, you're going to be left behind, right? So the reality is that's already been proven. For the most part, it was proven in the call center. Use a lot of those learnings, use a lot of those best practices. Hopefully you've established a center of excellence around AI that can provide leadership, mentoring, and assistance to the rest of your organization, but don't spend a lot of time trying to prove a concept to do a small POC, really, because that's been there. I think clearly we've already identified where the use cases that hunt are, right? Where are you going to save money? Where are you going to be more efficient? Where are you going to be able to perhaps do energy cost savings on your RAN by using some AI models that are already well matured and can be leveraged pretty much out of the box. And so that would be our one of our key learnings. With regards to our investment in that area, as I said, the Azure networking team has already spent an enormous amount of energy, dollars, people, kind of building out what we consider to be a leading edge framework or platform for agentic AI for use in the network. We are giving back to the broader community and packaging a lot of those best practices, a lot of those learnings in something that our telco community partners can still leverage to begin to build this capability using, again, a proven framework. So we announced it last June. We call it the Microsoft Network Operations Agent Framework, NOAA for short. NOAA is essentially the guidance that we've received from the Azure networking team that in the way they've created this multi-agentic framework, all these agents that I spoke about, in a way that you can begin to harness, to leverage, to use, again, without stressing yourself that you have to do a POC or a pilot. That's been done. It's been done with a number of customers. We certainly have great stories to tell with customers like T-Mobile, like AT&T, like Telefonica, that are leveraging a lot of these key capabilities already to run more efficient networks. And so, run, don't walk, and get these agents deployed.
I'm not sure the data center industry runs or works, but you build out stuff.
Yeah, I mean, to your original question, I think really in terms of the conversations, and Rick outlined a couple things really well, but for us the challenge is switching gears back and forth. One is We're just trying to build it to enable AI and AI clients and customers to deploy and service. And so there's this thought process of really base, of just build it as fast as we can, make it efficient. At the same time, and Rick, you touched on this, how are we using it? And we have to remind ourselves that not only are we enabling it, we need to find ways to make ourselves efficient. I love the POC comment because we don't have time. You can't sit and say, okay, we've got a year-long project, and some of those are still put forth, but it's too slow, it's gonna get past us. And so changing the mindset of our staff and our teams to say, hey, we're gonna go do these things today. We may fail, we may trip up, but it's a much better process. And frankly, using and leveraging the concepts and the tools within AI allow you to do that much faster, whether that's predictive maintenance or, a lot of our monitoring systems are allowing us to identify problems much, much faster and fix those. In our construction and development, some really cool, somewhat crazy things we've got. Describing it in the wrong way, but it's almost like a robot dog that is walking the site and comparing to our CAD drawings, down to very, very minute dimensions and identifying problems in the construction process while it's in flight. So we no longer have to come out and stop and audit and check. It's just happening in an ongoing way. So those sorts of things, as a user of AI are amazing. And then at the same time, how are we building and how are we delivering fast enough to meet the demands and the demands of our clients? Many of them, their demands are changing pretty frequently.
Are you guys seeing this in RFPs already?
Oh yes, yeah. Everything we're doing. I mean, the biggest shift, which everyone is talking about, is the requirements around liquid cooling. What is the solution? And there are 3 or 4 variations that are coming out, and so each of our clients have different specific requirements, and we can't just, we're trying to get to a standard, but we're not there yet because it is so new and it is so fast.
Well, I was just say be fast. And Geng, are you seeing that with your clients?
Yeah, so developing AI infrastructure has been a tremendously unique experience and a challenging experience. So basically, it's come down to how fast we can learn. That's a starting point. And how fast we can react. And the most challenging part is how far we can actually predict and forecast the future demand. So that's probably a billion-dollar question, but learning from the developers, working with the technologists, and very good industry networking, and willing to listen, and willing to be wrong and correct. So that's becoming basically essential. Everything basically is just happening 10 times faster, and we have to operate 10 times faster.
One of the differences I've seen with IOWN, really, and it's a great thing about moving from POCs, is proving business value. Are you all seeing that from a client? Now, it's about the value. How would you articulate the value looking at APNs and IOWN in general? Start with you, Rick.
It's interesting you point that out. Everybody here's probably read the MIT report from a few weeks ago that said 96% or 95% of AI projects fail or don't actually return the value that was expected. Now,
Bloomberg this morning again.
I'm not exactly sure where they got that info. It wasn't from my customers though, because we're all seeing absolutely incredible value. It's an interesting point. The reality, though, is that I think everybody here has probably used Copilot, ChatGPT, one of the generative AI chatbots. And once you make it a part of your day-to-day, it's hard to put the genie back in, right? It's just not going to work. As an example, with regards to ROI, in the Azure networking team, our operations staff, each engineer, each operations person that ultimately is handling incidents, can now handle 40% more incidents. This is a real stat, right? So that is because we have, again, this plethora of agents that are helping, either making them more productive, or in some cases, like in Miles, autonomously solving problems on their own. In fact, Miles, if he was a human agent, he would be the rock star operations person in our staff because he solves more issues than any other person combined. So absolutely we're seeing ROIs, but what are you measuring? And let's ensure that you're measuring the right thing and you're targeting the right approaches and the right problem set in order to see that value.
That's a tough one. I think, Rick, you touched on it. For us, because we are building the infrastructure to enable them to go after whatever that vision is, it's hard to quantify the value. And so for us, it's really the cost efficiency and the speed of delivery. When you look at the end result of what some of our clients are doing, some of them are no-brainers and it's clear where they're going. Some of them are much more speculative. What I will say is we try and assess that. We certainly want clients that are going to be with us for a long period of time and that can grow with us. And so we try and get a view and an insight into their business sooner rather than later. It's very hard, to be candid when you've got a deal on the table to say, hey, we're not sure your idea is going to work. But it is interesting to hear what that end goal is, rather than, what just deploy. Now, and so Greg talked about the Mark Zuckerberg quote. We use that a lot, which is this idea that our clients and the big providers are just growing with no end in sight and figure it out along the way. We love that. It's good for us, but it is a little unsettling that it isn't as clear cut of we're doing this today to deliver this tomorrow.
And Geng,
yeah, so as I mentioned earlier, so basically next generation platform, we are dealing with a three-dimension problem. So then the question really is, how much you want to actually these three, networking, computing, and data management, how you actually want to couple them, how tightly or how loosely you want to couple them. Then that's actually directly affect the complexity. If you integrate everything tightly together, the complexity shoot through the roof. However, if you don't, then how you actually manage the interoperability question. So those are things that we are working with our customers, we are learning, and that's the POC, basically, one of the aspects that the POC actually is looking into.
Thank you, and an apology that we've run out of time, things have flown. What I've learned today is that AI is a therapist, a lawyer, and now a rock star, if we take anything out with this. But also thank the guys here principally, and thank you all for watching, and hopefully see you again next year. Thank you.
Yeah, thank you.
Thank you.